When it comes to drawing an actual straight line, we have to sort of see the equation as a rule. So this first example here, y equals x minus 3, that means that every y coordinate is equal to the x coordinate, take away 3. So if we draw a little grid, then we can come up with a table of coordinates. So there's my x's and my y's. Now the rule is that the y coordinates or the x coordinates take away 3. So just choose any random x coordinates you like. It won't matter at all. So I'm going to choose 2, 3, and 4. Doesn't matter which ones I choose, but I'm going to choose them. And so the rule is the y coordinate is the x coordinate take away 3. So 2 take away 3, 3 take away 3, 4 take away 3. And now I've got a set of coordinates with my x coordinate being 2 and my y coordinate being minus 1. X coordinates 3, y coordinate 0, and then 4, 1 as well. And if I plot these here, so 2 across minus 1, 3 across 0, and 4 across 1. So you can see those are 3 lines. Now, if we picked another set of x coordinates rather than 2, 3, 4, we would just have got different points on the same line. So let's now join those dots, and this is where it gets tricky. It's easier with a real ruler, and as you can see, it takes ages to draw with this because you have to swirl it all around. Okay, so I think that's me joining, and you can continue the line over those points and just keep it going. And so that is the line x minus 3. And if we look at the equation here, we know that the gradient is the number of x's. So the gradient here is just 1, and the y-intercept is minus 3. So the y-intercept, it's not really a shorthand for that, is minus 3. And remember, I said back in one of the other videos that a gradient of 1, so it's positive, so it's going upwards from left to right, and it's also at 45 degrees to the x-axis. Okay, so that angle there would be 45 degrees. And it cuts the y-axis at minus 3. So that's exactly what we would expect. So this example down here, each y coordinate is 3 of the x's and the number 2. So again, we just make a wee grid, and then we just need to choose some coordinates. Now I'm going to be multiplying these coordinates by 3, so I'm going to pick quite small numbers. So I think I'll pick, I could do -1, or I could just make my life easy and do 0, 1, and 2, and not worry about negatives. So maybe we should do a bit of working here because it's a bit more complicated. So the first y is 3. So 3x plus 2, so the first x is 0, so that's 3 zeros plus 2, so 0 plus 2. Then the next one is 3 1s plus 2, so that's 3 plus 2. And then the last one is 3 2s plus 2, so that's 6 plus 2, which is off my grid. Now, because that's off my grid, I can either just do it, or I could actually just start again with I mean, it's, yeah, you could add on to your grid, but instead of choosing 0, 1, and 2, I will choose negative. So my laziness did not pay off there. So let's choose -1, 0, 1. That way I don't have to add anything to my grid. So my answer for it was 0, it was 2, and when it was 1, it was 5. So when it's -1, let's see what happens. 3 times -1 plus 2. So 3 times -1 is -3, plus 2 is -1. So that will fit on my nice grid. So -1 across, -1 up is here. 0 across, 2 up is there, and 1 across, 5 up is here. And you can, if you want to write the coordinates, so -1, 1, 0, 2, just to make sure you don't muddle them up. But as long as you do your x's first, it should be fine. But you can write that if you like. And then let's, so we just need to be careful joining these lines up. Oh. And that is the line 3x plus 2. So it's got a gradient of 3. So you can see it's going along 1 and up 3. That's the gradient of 3. And the y-intercept is at 2. Cuts the y-axis at 2. Okay, so y equals 5x minus 1. So I'm going to be smart this time and choose negatives and positives that are small because I know I'm going to be multiplying by 5. So I'm going to choose negative 1, 0, and 1 again. So 5 times negative 1 minus 1. So that's minus 5. Maybe my smartness didn't pay that off. Yeah. Minus 5 minus 1 is minus 6, which will just fit no more. 5 times 0 minus 1 is minus 1. And then 5 times 1 minus 1 is 5. Take away 1, which is 4. So my coordinates are minus 1 across, minus 6 down, 0 across, minus 1 up, and 1 across, 4 up. And then sketching my line. It'll be a bit more steep here because the gradient this time is 5, not a 3, so the line is more steep. And that's us. So we've got a gradient of 5. It's going across one box, up 5 for each wee step. If you look at that wee triangle there, going across 1, up 5. And the y-intercept cuts it at minus 1, and the y-intercept is minus 1. So we're fine. And the last one, y is a quarter x plus 2. So again, a wee grid. And I need to pick 3. You can do 2, because all you need is 2 points. I usually pick 3, or you could do some more if you want to be sure. So I'm going to be clever here, and I keep saying that, but I really am. When I'm doing my quarter of x, because I know I'm going to be quartering my x, I'm going to choose x's that are in the 4 times table that easily divide by 4. So I'm going to choose 0, 4, and 8, which is going to be off the grid, but if you'll forgive me, I'll just do that. So a quarter of 0 is 0 plus 2. A quarter of 4 is 1 plus 2. A quarter of 8 is 2 plus 2. So those are my coordinates. So 0 across, 2 up, 4 across, 3 up, and 8 across. I'm going to just guess that. And 4 up. It's going to be about here, but I'm going to rely more heavily on the first 2 dots because they're correct. So let's join them up. So I'm going to worry more about these first 2 dots because that last one is a wee bit out actually. Just going to cheat. Here we go. Perfect. You would never know. So that's my line there. And the gradient is a quarter because it's a quarter x. It's always the number that's multiplied by x that's the gradient. And as you can see, I'm going across 4 and up 1, and it's a lot less steep than the earlier ones. And the y-intercept is 2, positive 2, because it cuts it at 2, and that's plus 2. So I'm correct.